Welcome to day 2 of Next. We're really excited to have everyone here. How's everyone's afternoon going so far? How was the lunch? Free food, come on. Okay, so I want to set the stage here, pun intended. There's two really kick-ass developers that come up with this novel app idea, just like we all do. So they go back to their place and they start working on it. And they pull an all-nighter coming up with this app, and then they deploy it. They get a few users who start testing their app, and they love it so much. One of them goes on and submits it to Hacker News. Turns out Hacker News loves their app too. Quite an irony. They reach the #1 spot on Hacker News overnight. They get thousands and thousands of visitors. But their servers were not meant to handle that kind of load. They didn't do demand projection, and so they could not know that that would happen. And so it takes them hours the next morning to provision more capacity to handle this additional load. But by then, it's a little bit too late, and they've lost a lot of users. In an alternative universe, you have a team of developers who come up with the same app idea, but this time, they spend a little bit more time architecting their app based on the best practices like microservices, and then they deploy it to App Engine. This time also, they didn't have to project any demands, know how much traffic to expect. The only thing they did was deploy to App Engine. They go get a few users to beta test their app. The users love it so much, they submit it to Hacker News again. And again, it gets thousands of visitors. But this time, based on the load that the app is getting, App Engine is able to scale up their servers to handle that additional capacity. They're able to capitalize on this success, go raise more money, and hire more people. So let me just take a quick poll in the room. Who would rather be in the first group? Raise your hand. Who would rather be in the second group? A few people. So I've done this poll before in my dry runs, and unanimously, everyone wants to be in the second group. And my goal with this talk, my goal with this talk is to really motivate you into giving App Engine a shot and learning a little bit about what the second group did. Hi, my name is Karan. I'm a software engineer working on App Engine for about 9 months now. And today, I'd really like to talk to you about how you can write scalable apps, high-performance app that run on App Engine, and how some thoughtful decisions while you're making your app can make a huge difference in your performance and scalability. We'll be doing a lot of cool demos, and towards the end, we'll be taking down a data center. It's going to be a lot of fun. So let's start with the basics here. What is App Engine? How many people know about App Engine? How many of you have used it? Ooh, a lot of people, wow. So I'll just keep this short. App Engine is a fully managed platform to deploy and run your web applications or API services, with a caveat that you don't have to worry about lower-level infrastructure. It's what we call serverless infrastructure, where you just deploy your code and don't worry about servers or infrastructure. The goal of the platform is to abstract away all the complexity that comes with managing this infrastructure. And we just want you to do what you do best, which is write code. And we enable that by setting up a lot of services behind the scenes while you deploy your code. We want our users to have the same tools and services that we've been using at Google here for many, many years. We want you to focus on your business and growing your business, and not have to deal with servers and reinventing the wheel. Some of the services that we offer are things like logging. Hey, what's going on in my app? Monitoring. What happened at this peak? I want to know what happened at this spike. Autoscaling for cases when you don't know what to expect, how much load to expect, and we can automatically add and remove capacity. Health checking to make sure the servers that are serving your traffic are healthy and up, and load balancing to make sure all your servers, again, are healthy and don't get too much traffic. All these services let you execute really fast, and all you need to do is either enable one option or write one line of code, and you'll see these in demos again. As developers, we just want to execute fast without having to worry about scalability or complexity or reinventing the wheel. Together, they all work to make sure you can go from code to Google Scale in moments. In short, you bring the code and we handle the rest. And if you've gone to any other App Engine session, you might have seen this slide before. It was in the keynote earlier today. And this is the philosophy that the serverless infrastructure at Google lives by. You bring the code and we handle the rest. And all of this works to set App Engine apart because you can use the platform whether you have your first 10 users, your first 10 friends and family members, or the next 10 million users. So let's kick tires with a very simple demo, Hello World demo. I have for those familiar with Node.js, this is a simple get handler in Express.js framework. All it does is handle the root path, compute a bunch of hashes, and then update Firebase, and you'll see why that happens. Finally, it returns hello world with the last hash it computed. So this is a normal everyday app site that I can run on my local system with Node run or npm start or Node run. Or I can run it on Google's infrastructure. And the only thing that that's different is a two-line config, this two-line config. App Engine uses this file called app.yaml, which sets the configuration for what your app's resource requirements are, what the network settings are, things like what service to deploy to, what network settings to use. So here is my app YAML that I'm using. The first line tells App Engine that it's a flexible environment app. The second line tells App Engine that it's a standard Node.js runtime app. To deploy this, all we have to do is gcloud app deploy, and within moments, your app is set for the world to use. So let's go to a simple demo here. Thank you. So I'm in my cloud console here with my app where my app is deployed, and you can see there's one version deployed. I'm going to do something real quick. I am in my a GCE instance, and I'm starting a Locust web server. And I'll explain what Locust is in just a second. So what I did here is Locust is a load testing tool, much like Apache Benchmark, but comes with a web GUI. And I am sending a peak of 200 users at a rate of about 20 per second. So they're growing at a rate of 20 per second. So just to show you what my app is, again, I don't have anything up my sleeves, wrong tab. It's a simple hello world at the hash of the last timestamp. So as you can see, I have one version deployed, but 2 instances running. It's a Node.js app running in the flexible environment. If I go to my Instances tab, you can see I have 2 instances running right now. Now, I could just claim here that autoscaler is running, and as my load is increasing, we'll add more instances, and you'll be all good. But that makes for a very boring talk. So what I'm going to do is explain in 30 seconds how autoscaler is working. By default, it's looking at CPU usage across all my instances, and if it reaches 50%, it starts adding more capacity. And this is something I can configure. I can change it to 20% if I want to be below 20% CPU all the time. Or I can make it 80% if I want to use my resources up to that extent. So all of this gives you very fine control over your particular app and your specific needs. You can also configure the minimum and maximum number of instances. I didn't do that, so by default, I got 2 instances. But if I want 6, I can set 6. If I want 2,000, I can set 2,000. So this lets you plan for your budget, knowing the minimum and the maximum instances that you can set. So now, as my app is getting more and more load, I will switch to this simple web app where you can see the 2 instances and the other 3 are from my previous testing. The two instances up there are getting requests. So what's there is these compute icons represent the two instances that I have in my app that are serving traffic. And the pink bubble with the number in them represent the number of requests each one of them has handled so far. So one of them has handled 14,000, the other one has handled about 8,000. And this is not an App Engine thing, this is just something I wrote for this demo. So now as my app is getting all this load from Locust at about 166 requests per second, App Engine has already started all these instances knowing that my requirement for CPU has increased, and there's 7 instances, I believe. And anytime now, they should be, there we go. One of the instances is now serving more requests. So this is the one very simple demo where you can see instances are being added. And as my load will start to go away, these instances, the unused capacity will also go away. And if we could switch back to the slides, please. So the Hello World app scales just fine, and it's a very simple example where I compute a bunch of hashes that consumes some CPU. But that's not very interesting. That's not real life. Real life is something that has many moving parts. It makes a bunch of service requests. It does a bunch of database saves and reads. So we're going to try doing that. For this demo, I'm going to make a small part of Google Photos. Who's used Google Photos here? A lot of people. So in Google Photos, you can, of course, upload your photos and then search for them, which is the coolest feature, by the way. So we're gonna try to emulate the labeling feature, and because it's a demo, I'm gonna keep it simple, and all we will let our users do is upload an image and then see the top labels that the Google Cloud Vision API is able to find for those images. And because I don't have millions of users, I have maybe a couple hundred in this room, I'm gonna try to simulate that load using the images I found in this data set, again, provided by Google for free. Oops. If we could switch to the demo again, please. Thank you. So just to explain again what is going on, I have one photo here of this construction site, and I have a simple web page that is blank right now. If I switch to my terminal and upload this one image, what's happening in the background is my server is getting it, calling the Google Cloud Vision API, and then saving the labels in Cloud Datastore, which is a NoSQL database by Google. So now if I refresh my page, you can see these labels are in, and the CSS is a little bit. Okay. These labels were extracted from that. So now we want to do this for thousands of images. Can we switch back to the slides, please? Thanks. So one implementation, which is the easiest implementation, is have one application, one monolithic application that handles the post request and the get request. The post says, hey, here's my image, save it, get the labels, and then save those labels. And the get request will then return the whatever result we want to return. But this really isn't ideal because packing resource-intensive requests with user requests on the same machine can cause your application to crash. If a lot of my users are uploading their images and I'm running heavy processing on the same machine that has to respond to user requests, this can result in very high latencies for my users. And if for some reason my post endpoint is down, that means my get endpoint is also down. So this really is not the best implementation we can go for. The solution here is to architect our application with microservices architecture. An app engine in its foundation has microservices in it. Each application can have multiple services which map to each type of request. And each service that you can see on the graph, which is the second row, is fully isolated from other services and can be invoked by HTTP requests. Further, each service can have multiple versions, and each version corresponds to, say, your releases. So if I have a V1 and I have a V1.1, each of those can be a separate version that I can send different amounts of traffic to if I want to. So knowing that, we can decompose our app into these two services. The one on the left, the vision service, is the post endpoint effectively, where my user submits an image, we do some processing and save the result. And the web front end, which is the service on the right, serves an HTML page with all our top labels. But this also is not ideal. And we're still running into the same bottleneck that if my users submit a lot of images at the same time, the request will start getting queued up because my resource-intensive process is taking a lot of time. And eventually, they might even time out, which means my users won't be able to upload more images. This is not the user experience that we want to have. And this can be solved with autoscaling, but only to a certain point, because you'll be spending a lot of money having all those servers up. So to fix this problem, we again decompose our app into these three services, and I promise this is the last one. The Vision API service, the one on the left side, is just the plain post endpoint, and all we do there is when we get an image, we send a message to PubSub, which is our worker queue. The one in the middle, the Vision backend, does the heavy processing of that image, whether that's running ImageMagick, whether that's running your own custom machine learning model, or in my case, calling Google Cloud Vision API. And the one on the right is the same front-end service we have. So PubSub, for those not aware, is a message queue to talk between independent services, and it's also not an App Engine concept. It's a cloud service, which is available from all layers of compute. So finally, after all of this work, we have this pretty solid but extremely scalable architecture that follows App Engine best practices. I know you're thinking, this is a pretty scary graph. So I'm going to take some time to walk through each individual component and explain as I've implemented them. So first, we have the Vision API. And all this is here's my image, please save it. In my case, I wrote it in Go, and it publishes a message with that image to PubSub. In the center of the slide is the Vision backend, which receives the image through PubSub from the Vision API. It then calls Cloud Vision API, which is one of our ML machine learning APIs, takes the labels out of the response, and then saves it in Cloud Datastore, which is a fully managed NoSQL database. This service is written in Node.js. And if you've noticed, I can have different languages in each service. So because my user-facing API has to be really fast, I implemented it in Go. This could be in Node, so I wrote it in Node. And on the right side is my web front end, which is the front end that my users will use to see a list of all the top labels they have. This will pull results from Datastore, and also this is written in Node.js. So I can really mix and match the languages I want that are best for the use case that I'm writing my app for. And if we could switch to the demo real quick. I want to do a quick walkthrough of the code here because code rules. So just to show that there's no shenanigans going on, I'm just going to do a quick walkthrough of the code. And this is a simple Go server for our Vision API. What I'm doing here is initializing my PubSub client in 3 lines of code. I am subscribing to the topic, and then I'm initializing the Firebase reference. This is, again, for visualizing in the web app. In my endpoint, the meat of my endpoint, I'm extracting the URL that's coming from the request. And then after that, I publish it to Cloud PubSub right here. And if you notice, again, it's a single line of code to do all this complicated worker queue communication. And then finally, I update right here. I update Firebase with this instance's name. Next, we have the vision backend. This is the backend that does the worker that listens for new images and then does the processing. And similar logic, we initialize our Firebase client. I initialize my Cloud Vision client, and then I initialize my Datastore client. When I run my server, there is only one endpoint that I have that will extract the image URL and then immediately return a 200 response to the client for faster latency, lower latency. Then we download the image and then call the vision client detect labels method. And this will call the compute vision API, extract all the labels, and we dump everything that we're not very, very confident about. So the 0.75 filter there. And then finally, we store all our labels in Datastore, and the mapping here is the label mapped to the count of the label we've seen so far. So very simple. After we save our Datastore client, we again update Firebase for tracking that instance. Similarly, in the last web frontend, we initialize our Firebase client, our Datastore client. We allow cross-origin requests. And then in our home page, we render static HTML page. And then we have a simple JSON endpoint labels, which will query Datastore to get all our labels up to a certain limit and sort them. So again, single line of code to get to query Datastore. And then finally, we return the response with our keys. So let's play with this a little bit. I already have a version of this deployed, and I'll do something similar to what I did before. I am in my locust instance here. Oops. And this time I'll send up to 300 and ramp them up at 20 users per second. So what's happening here is, and we'll be able to see it better here, I have one instance running, and I could set this in my app YAML. I have one instance running that is doing, that is handling all my front-end requests. Now I'm going to simulate some users by sending 1,000 image URLs at a pace of about 5 per second in batches of 5. And this is just a simple wrapper around curl, which sends 5 of them at the same time. So you can see my Vision API has started getting some requests, and my backend is starting to process them. So while this is happening, I want to show you the Cloud Console again and go to the Services tab this time. You can see I have the web frontend with one version running. I have the Vision backend with one version running. And I have the Vision API with one version running. Vision API is in Go with one instance. Backend is one, Node.js. And the frontend is 4 instances now. So within the last 30 seconds, Autoscaler figured out that our load has increased and already started spinning up these instances. And this one, again, is in Node.js. So while my app is warming up, if we could switch back to the slides, I want to point a few things out here that I just slightly glanced over. First is just the breadth and the depth of services and APIs that Google Cloud Platform has to offer. We've been doing technology for 18, 19 years now. We've been working on machine learning for a decade now. And we would like our users to have access to all of those cool services, from databases to machine learning to monitoring that power product like Google Photos. And you can have access to all of that, and as you saw, all it takes is a single line of code. And second, more specific to our app, is each service is very specific and independent, and there's one thing it does, and it does it really well. We make sure our latencies are extremely low. We make sure they can scale up and down on their own. And as my teams start growing, they can control their own independent deployment processes, further bringing the risk of rollouts down. Third, if my Vision backend service is down, it doesn't hinder with my user experience of the API or the front end. And that is something really powerful, where even if some of my system is down, most of it is still up. Finally, and I mentioned this before, my services can scale independently. If suddenly my users want to show off my app because I'm at a conference like this one, only my web frontend can scale instances up, which results in better use of resources and hence my money. So let's see how our app is doing, and if we could switch to the demo again. Perfect. I go to my instances tab here, and you can see we've spun up 15 instances. Not sure how easy it is to see back there. We've spun up 15 instances, and web frontend is already serving my request with 3 of these instances now. And this is something really powerful, where we only had to wait for a few moments to see this almost real-time scaling happen. And so while we are still here, I want to go back to my default service, and this is the service that I used in my first demo for the Hello World with hashing. And what I want to show you is the monitoring that we provide with our service. And you can see in the summary graph, we can show you how many requests per second you were getting. So I was getting about 180 or something like that. The second one I want to point you to is the CPU utilization graph, where you can see a nice curve of how my CPU utilization was happening. And based on this, I can again plan for my peak hours. And finally, and this is the coolest one, is the instances graph. And you can see again, for the longest time, we were at 2 instances, and then the CPU load increased, so autoscaler scaled my instances up to 6. So this really gives you a peek at how autoscaler works, and that's what we want you to have, transparency. The one thing I should mention is this scaling is happening based on the CPU consumption, but you could configure it to be QPS, or requests per second as well. Okay. If you could switch back to the slides. Thank you. Okay, so for the final demo, and this will really highlight how resilient our infrastructure is. I promised I'd take down a data center. I'm sorry, I lied. I couldn't get all the approvals. There's processes and customers that we need to take care of. So we'll do the next best thing, and this will still be worth your time. We'll pretend that a data center is down. So for some context, all App Engine deployments are multi-zonal. Whenever you deploy, you can choose a region to deploy to, and within that region, we add a layer of replication across multiple zones. So on screen here, you can see some of our regions, and each region is in the blue row. And within each region, we have multiple zones. So in my case, I deployed to US Central, which has 4 of these zones. So my app is replicated across 3 of those. And that really happens to manage failures and improve latency. And as some of you know, failures in data centers happen. Some of you might have had outages last week. And so what I want to show here is, if there is a data center outage, we can still be in a good position. If we could switch to the demo here. OK, I'm nervous for this one. I'm not going to lie. So I'm going to tell you what's happening here. I have the same Hello World app that I used in the first demo. And I am going to start my local server. And we'll do 200 users, ramp it up at 5 per second. So I have the same Hello World app, and I would be happy to show you the app. So all it does is Hello World. It does some hashing, and I'll show you the code in a second. But this time what's happening is, in every request, it looks at the metadata of the server. So each project has metadata, and each instance has access to that metadata. When it sees that the app is currently in a zone which we want to take down, it responds with a 500. And this happens for health check as well. And the health check bit is important because that's the signal that autoscaler is using to take instances in and out of rotation. And so what I'm going to do, and we'll switch back to this app. Oh, sorry. Yep. So you can see I have 4 of these instances currently serving my request. What I'm going to do is take down US Central 1A. And so what this command does is it updates the project metadata to have this failure zone field, which is currently set to US Central 1A. And as soon as that is done, okay, so it's updated. So it looks like none of our VMs were in US Central 1A. So just for theatrics, I'll take down another zone. So now if you notice, US Central 1 had 4 zones, and I'm pretending that 2 of them are down. Half of the region is completely down at this point. And at this point, if our VMs were in the correct zone, well, it looks like demo gods are not on my side. Oh, no. OK. Anyways, we'll keep moving. So with that, I promise there was no magic here, so I'll show you some of this code and how I implemented this. This is, again, in Node.js. I'm curious. So the way I implemented it, I have 3 endpoints defined, one for the zone of the current instance. OK, there we go. 2 of these instances are out now. Whew, thank God. So if you notice, the second instance and the 4th instance have stopped serving requests. And I don't know what happens next. The failure zone 1 is a custom field I defined, and the failure zone 2 is a second field I defined. I do the same Firebase initialization. And then before I start my server, I query my metadata server and set the app zone field. And so this is just telling me I'm in US Central 1 B, C, A, F. And then I have this AH health endpoint that I define. And what it does is it gets the metadata from the first attribute field and then checks to see if my instance is in the same zone as my app. If my instance is in the zone where I want a failure to happen. And if it does, it short circuits and returns 500 status code. If it doesn't, does the same thing for the second one, and then short circuits with a 500. In my root path, I check if we are in a failure zone again, if the fail bit is set, and if it is, send 500, otherwise do the same hashing to consume some CPU, and update the instance. And then finally return hello world. So this is really, really testing our infrastructure. And if you notice, another instances was just spun up, but these 2 instances are still not serving any traffic. And soon enough, they'll be gone as soon as those instances are terminated. So what happened here is more and more of these requests are coming in, and more CPU is being used. And Autoscaler noticed that and then tried to add more capacity, but the instances never went healthy. So it never added them to the rotation where it can start serving the traffic. So the load balancer never sends the traffic back to those instances. And I think that's a really cool thing for us to see. And you can see we're up to about 35,000 requests to our instance now. OK, so if we can go back to our slides. OK, so what did we learn today? Well, first of all, demos are really freaking hard. Practice this a lot of times, but something unexpected happens. But on a more serious note, we are all spending hours and hours writing the best code that we can. We're going to conferences like these and learning the best practices. But it really sucks when a machine cannot play nicely with our code, and that happens all the time. You know, some machine goes down, someone else makes a typo, and something happens. So it's really important to defer managing those machines to people who've been doing this for many years. And this really lets you focus on your code and writing the best code that you can write. Second, some thought in architecting your code and following some best practices goes a really long way. Think about all the places where your app might be doing too much, and then break it up. This keeps your deployments and rollouts independent and reduces risk when you do have to roll back a release. This also makes sure your resources, as you saw, are being used more efficiently, which means a better use of your money. Finally, I would invite you to try App Engine. Give it a shot for your next project, and it might just surprise and delight you. If you're curious to learn more about App Engine, there's a couple more sessions going out tonight and tomorrow. And with that, I'd like to thank you for attending this session, and I can take some questions. We have questions? Yes.
Hi, thank you for the wonderful talk. We'd love to get more thoughts on your decision to do the vision backend behind a pub sub. I see you mentioned you're trying to throttle the amount of CPU scaling. Can you tell us more about that?
Sure. So PubSub is, I'm just using PubSub as a queuing mechanism, because if my server doesn't ACK to PubSub, PubSub will keep retrying. So I could have used 0MQ if I wanted to, but PubSub is just something I can use on cloud's infrastructure, on Google's infrastructure.
But in what case would that try to increase more instances? Because your web front end kept adding instances.
I see what you mean.
Yeah.
So if PubSub keeps sending too many requests, if my users submit a lot of requests, and PubSub is sending, enough requests to hit my CPU threshold, then Autoscaler will add more capacity to it. And so it doesn't matter how many requests are coming in. From Autoscaler's perspective, for my app, it's the CPU consumption. So I could compute 100,000 hashes in one of the requests, and if that takes enough CPU, that's the metric that Autoscaler will use.
Thank you.
Yeah, you're welcome.
Hi. Kind of had two questions. One is about PubSub for breaking apart work versus task queues. When would you choose one over the other? Because I know task queue has some nice features, like you can pause work in the middle and restart it or do stuff like that.
Right. Go ahead.
Yeah. Oh, and the second question was just like, for the microservices architecture, how would you keep all of those separate services in the same repo as folders and then have one app YAML file that says like, here are all my services for this application, or do you break it apart? And because something we've kind of started toying with, and for us, we do drone deployments, so we would have to have a huge drone YAML file to deploy each part of the repo for each service. So I'm just curious how you would approach that.
Okay. So for the first part of the question, the PubSub v. Cloud Tasks, PubSub is really more of a real-time messaging platform. For this app, I could have used either, but if I wanted very low latency real-time communication between, say, my mobile app and my backend server, that's where I would use PubSub more. Cloud Tasks is more of it's more for server-to-server communication at this point. It did emerge from App Engine itself, but you can still use it within any layer of compute, if that adds some clarity. For the second part of the question, it's about repos.
Just how you would organize those microservices and deal with deploying the services independently.
Okay. I think that really depends on how you would have your deployment process. I think it adds a lot of value to your organization if each of the deployment process is separate, because again, it reduces the risk. You don't deploy one large monolithic. So I think it would make sense to have a separate deployment process for, say, your front-end service, where one of the team takes ownership of it. For organization of the code base, I would say you could have the same app with multiple folders, each one corresponding to your service, but and then you could maybe have some wrapper scripts that CD into the directory and do a gcloud app deploy, and then break out if something goes wrong.
Okay, thanks.
Hi,
Hi.
we have a app that's running in the standard environment in Java, and I was wondering what the future of supporting like later Java versions is in the standard environment, or if it's something where we should start looking towards migrating to the flexible environment.
Um, I'm going to have my PM, Justin Beckwith, answer that because he knows more roadmap stuff.
Yeah. Okay. Yeah, so, whoa, that was loud. Yeah, the standard environment isn't going anywhere. We're continuing to invest in that. One of the announcements that we actually had, for those of you that are part of the Cloud Insiders group, is that actually our support for Java 8 went alpha last week on the standard environment. So we're going to continue supporting that. We're going to continue growing. We're going to get new languages, later versions of languages. It's going to keep getting better, and both standard and flex are going to do that at the same time. The one thing that is going to change that you should be ready for is how we support the libraries that you run within these runtimes. Today, when you want to access something like Datastore, Memcache, task queues, you're using a very specific kind of library for App Engine. What we've been doing is writing these things called the Google Cloud Client libraries. We have them out on GitHub, and the idea is that we want to be able to use the same libraries for App Engine, Container Engine, Compute Engine, and be able to access, all of our services, not just databases, not just the App Engine services, but things like CloudML, the Vision API, a lot of the demos that Karan was giving today. So when you start thinking about how you're writing your apps in standard, any opportunities you have where you can use those Google Cloud Client libraries, for Java, there's a very good one. Start looking into that, and you're going to see better support from us in the next couple of months there as well.
Hi. I was wondering in App Engine Flex specifically, how do you deal with a sudden spike in traffic? All of a sudden you went from 2 requests per second to 5,000. How fast do the instances spin up in order to not lose requests?
So in my experience, it's ranging anywhere from about 1.5 to 2 minutes. So if your traffic is extremely spiky and it spikes up within a minute or 1.5 minutes, then you're going to lose some traffic. But if it's for a sustained period of time, then we'll be able to add more capacity to that.
Okay,
Yeah.
thanks.
We're working on making sure we bring that down by a lot, though.
Okay.
Yeah.
Hi. Can we use Cloud CDN with App Engine, load balancer?
I believe you can.
I saw the documentation. I think it just works with the load balancer.
I'm not sure, so I'm going to defer that.
Yeah, so that's something that we're still working on, actually. We're actively building that out, but you're going to be able to just use the standard Google Cloud CDN, hopefully next couple of months. We don't know exactly when yet.
And just, I think, how many maximum instances we can have for per project or per services?
You can request, I think by default you're limited to 24 cores per region, but you can, if you want more, you can request more up to thousands of instances. So if you need many tens of thousands, we can work with you and make sure we have enough capacity. But we have customers running tens of thousands of cores, hundreds of thousands of cores.
Thank you.
Yeah, my question is regarding what is the comparison with the AWS Lambda and the other, Elastic Beanstalk, where App Engine features between the two, in case you are able to?
I haven't used either of those, but I believe AWS Lambda is more event-based, kind of like Google Cloud Functions. Yeah, I haven't used those either to make a comment about that.
Because Lambda automatically provisions whatever, the compute and all it's serverless, right? So
right. So the one difference I think is, we're also serverless, but here you get a little bit more flexibility in that you can SSH you're still able to SSH into the VM if you have any issues that you're unable to debug. Yeah.
thank you.
Hi.
Hi. There isn't currently a cloud API for caching equivalent to Memcache in App Engine Standard. So what's the guidance on running a caching fleet when connecting from Flex?
Just didn't know that.
Sorry. Yeah, so we have a cloud memcache service that's currently in alpha. So if folks are interested, pop into we have a Slack channel for App Engine, by the way, and we can, or contact Karan, and we can get you in touch for that, signing up for that if you're interested in getting in on the alpha. The other thing that we have is we have a partnership deal with Redis Labs, is one of our preferred partners for providing Redis and memcache solutions, and they run in the same zones that we're running App Engine Flexible. So if you're looking for memcache, either of those are good options.
Okay. Well, thanks for attending, and make sure you check out later tonight and tomorrow the 2 other sessions about App Engine. Thank you.